Alright, so let's look at this question here, which is taken from the year 1995, paper 1, question 16. I think this is a pretty interesting question. I like it when when one of the students actually texted me. Yeah, let's see how I can do this proficiently. I think for the first part, using substitution is okay. We are told to use a substitution to show that this expression here equals to this one. So hence, by using partial fraction, find the exact value. So I'm just going to do this quick. So let u equals to ex. Alright, so du dx will just be ex, and after which 0, 1, ex minus 1, ex plus 1 dx. This is important in the sense that we need to change this to u. This is u. And remember, this is x equals to 1 and x equals to 0. So if you change this to u, this boundary condition needs to change as well. You need to change to u. So this is what you're going to do. This is something which students always forget to change, which is the boundary condition here. So let me just write it down nicely for you. This part here will be when x equals to 1, u equals to e, and when x equals to 0, u equals to e to the power 0, which is 1. Okay, so this case here, this case, once you change to u, so I'm going to change to u. So ex is u minus 1 u plus 1. Dx, on the other hand, dx is actually, if you rewrite this properly, this will be dx would just be du over ex, right? But just substitute dx, du over ex out. So this will be du over ex. And because now you change to u already, so this will be u equals to e and u equals to 1. Okay, just bear in mind. So essentially this is just e to e and 1 here. So once this is done, what we're going to do, this is u, so that's pretty okay. So e1 u minus 1 u plus 1 du. Is that what you need to show? That's what I need to show, is it? Yes. Okay, great. Let's look at that. Then after which the next part would be find the exact value using partial fraction to evaluate that. Okay, that's pretty okay. So I'm going to use partial fraction for this. Partial fraction will be just a over u plus b over u plus 1 for this. This is factorizable, so and it's linear, so this is a case. I'm going to use carve out method. So 0 minus 1, 0 plus 1. So this is minus 1. B will just be negative 1. So if those of you who are not too sure what's carve out method, please go and check our notes, right? Under sigma notation and also in integration, we've done quite a bit of what they call it, partial carve out method. So this case here, once done, we get e1 over e, u minus 1 u plus 1 du will just be 1e, and a will just be negative 1 over u, b will be 2 plus 2u plus 1 du. Okay, so this case here, what we're going to get is minus ln u, then plus 2 ln u plus 1 e1. And I'm just going to substitute it in ln e, which is 1, 2 ln e plus 1. And after which I'm going to substitute in 1 minus, let's be very mindful, minus ln 1, which is 0, plus 2 ln 2. Okay, so that's about it. So this is the exact value, I presume. So this is minus 1 plus 2 ln e plus 1 plus 0. This is 0. This is 0, right? So it's minus 2 ln 2. Okay. And this case here will be minus 1. If I were to simplify this, be 2 ln e plus 1 over 2. Yeah. That's how we do this question here proficiently. Then we're going to look at the alternative method. Let me just move this over. Okay. Let's look at the subsequent one, which is to suggest an alternative method. Let's see how we can do this proficiently. So find the exact value of this. So I'm just going to copy that down first. So 0, 1, ex minus 1 over ex plus 1 dx, right? Is it okay? So I think that's pretty okay. So once that's done, what we're going to do is actually just trying to split this up. I understand that this may be a bit like difficult, but because now we can't use the substitution, and actually by splitting it up, what you can tell that is that this would be able to do cancelling method straight. Okay, so those of you who refer to the notes, you'll be able to tell that this is a cancelling method. But this over here, if referring to the notes as well, need rearrangement. Yeah. Okay, so this one need to be rearranged. So your answer for this last part should be equals to what we found previously. Anyway, you could actually check your answer. Just make sure that you use your calculator to check your answer. Okay, you can actually just key in calculator to see whether your answer is correct. I forgot to mention that. So what we could do is just go to math. Use this expression here. Especially this kind of question, you could just use this. Alright, to just evaluate whether your answer is correct. So key in whatever you found here and key in whatever is here, it should tally. Now this case here, what I'm going to do is I'm going to split it up. So this part here will be like 0, 1, ex plus 1. So this is my u. Dx minus, this will be 0, 1 over e. This needs rearrangement because you can't possibly integrate it straight. So what you do is just multiply with e minus x. Okay, now then the next question will be, how would you know? Then my answer to that is just keep practicing and you'll be able to see this. You have to be able to tell this is like quite a common expression in H2 mathematics, right? Where you have 1 over ex plus 1, you need to know that you need to rearrange it as such so that this then can use cancelling method. So this is cancelling method. You can actually use cancelling method here. So I'm going to use cancelling method. Okay, please refer to the notes. I am not going to, okay, maybe I should just, u is here, right? It's du, right? This is ex, cancel, right? So it'll be ln u. So this one I'm going to get is ln ex plus 1, 1, 0. This over here, remember, if you, maybe a side note here, cancelling method here will be e minus x u du. This is u minus e minus x, cancel away. This will be 1 over u du, which is actually minus ln u. Okay, so that's the case there. So what I'm going to get is actually negative ln 1 plus e minus x, 1, 0. There you go. Once done, we're going to just substitute ln e1 plus 1 minus ln e0, which is 1 plus 1. I'm just gonna 1 plus 1 like that. That's cool. And then after which we're gonna get ln 1 plus e minus 1 minus of I. I'm just gonna absorb this negative in out. Okay, so this would be just plus. So this will be ln 1 plus e0. Ta-da! Okay, great. So once this is done, it will be ln 1 plus e minus ln 2 plus ln 1 plus 1 over e minus ln 2 as well. Goodness. Okay, great. So this is minus ln 2 here. So minus ln 4. Ln 1 plus e plus ln e. Ln 2 minus ln 2 will be minus ln 2, right? So it'll be ln 2 times 2, but okay, maybe I should just e plus 1 over e here. This is ln 2. Okay, there you go. I suspect that this is the same expression as this. There's a minus 1 here, so how do I get the negative 1 there? Negative 1, I think you could just leave it as such. It's fine. 1 plus e times 1 plus e over e. Oh yeah, there I see the negative 1. This e here is negative 1 minus ln 2, 4. There you go. So this e is negative 1 here. So let me just rearrange this part here. It's just rearrangement, okay? So just ln, what do I rearrange? Yep. 1 plus e square over e 4. The 4 will be below. So this is ln 1 plus e2 square minus ln e, which is actually 2 ln 1 plus e over 2 minus 1. Actually, you don't need to rearrange. You can just leave it as it is. I think it's pretty okay. So that's how we do this question here proficiently. Now, any question, please let us know. Keep practicing, and I'll see you in the next question. Bye.